Birdie Rose was born with a disease no one had heard of or understood. As a toddler, her biological parents left her at the hospital. Though she appeared fragile, her destiny was to be strong. Those close to her see her as a force of nature.
There's something very intriguing about Birdie.
What we knew about Birdie was that she was an abandoned baby.
Not knowing her birth history, that also becomes quite challenging.
The first thing I thought is that she has some sort of progeria or premature aging disease.
There was some mobility issues in terms of walking. So when we have a child with dysmorphic features and developmental delay, we always think of a genetic syndrome.
The solution for the profound emotional trauma accompanying a rare disease like Birdie's lies in the intricate sciences of omics.
Omics sciences refers to the shift from studying, for example, genes or clusters of genes to studying all the genes in a cell or an organism. So the word omics is actually a Greek word which means all. So when we study genetics, we're studying a few genes, but when we're studying genomics, we're looking at all of the genes in the DNA in a cell or an organism.
Born with a disease unknown in South Africa, a treatment or cure was not yet discovered, but there was hope that the answer would lie in the field of genomics.
Sometimes in rare diseases we don't have a treatment because we either don't know that the disease actually exists, or we know about the disease but it's very rare and there's little information available about it, or we just don't know just yet how to design such a treatment.
Professor Chris Foster finds it frustrating that researchers often do not share information. With a database, access to others' research and whole exome sequencing, Birdie could have been diagnosed earlier. On average, diagnosing a rare disease takes more than 7 years.
I think now in the era of gene therapy and very specifically designed therapies, there's a lot more treatments available for rare disease patients. And in fact, 40% of new drug registrations with the FDA is for a rare disease condition.
South Africa's Department of Science and Innovation, the DSI, supports a research infrastructure program called Diplomics, modeled after a similar initiative in the European Union.
The idea is to create an intense resource that would be difficult for any one institution to build themselves. So this program is meant to place different types of scientific and technology resources in the country. So happens we're the only one that's right in biotech. And even within biotechnology, we're focused specifically on the omics sciences.
Among the research facilities in the Diplomics network is the Center for Human Metabolomics at the Northwest University.
About 2 years ago, we launched a pilot study to look specifically at using omics technologies to diagnose rare diseases. And it was quite successful. And then we decided to actually turn it into what we call a high visibility, high impact project.
The initiative was aptly named Nngwe, meaning one in one of the indigenous languages.
Meaning the one disease, the rare disease. It also means the one solution.
Nngwe is not only supported by Diplomics, the DSI also remains actively involved in its activities.
The intent of Nngwe at the end of the day is to diagnose patients with rare undiagnosed diseases.
Patients are admitted to the program, samples undergo analysis, and the resulting data are shared, making it accessible to scientists.
We want to open it up to our clinicians and scientists so that there's large-scale involvement in Nngwe. So essentially what we want to do is we want any clinician or scientist or even a paramedical person who has an interest in rare diseases to be able to participate in the diagnostic process.
The Birdie Rose case underscores the need for coordinated efforts among specialists in diagnosing and treating patients with rare diseases. Birdie was left at the hospital at 18 months and later found foster parents Kim and Leanne at the age of 2.
From the beginning, it's been very obvious that Birdie does have challenges, but it's been our challenge to kind of figure out what those problems are.
Both Kim and Leanne fulfilled their dream of working with children by founding Holla, House of Love and Hope, approximately 13 years ago. Today, it provides a loving home for around 22 abandoned babies and children, including those with special needs.
We have our baby house, our special needs house, and our toddler house. Generally, it's 6 in each house.
The intention at the time was we'll have one child, we'll see them through until adoption or reunification.
Over the years, the two women have embraced parenthood by adopting 2 special needs boys. They are in the process of adopting Vera May, who also has special needs, and Birdie's adoption will be finalized in the near future.
It is a big responsibility, but they're an amazing bunch of children. They bring lots of joy.
Leanne actually went to the hospital for another case with a different child, and Birdie just happened to be in the cot next to the child that Leanne was seeing.
The information in Birdie's medical record was almost overwhelming. Leanne needed a coordinated team to help provide support and the right medical care for Birdie's ongoing journey.
I remember going through all of her records and discharge summaries and just trying to figure everything out. There was about 5 different hospitals she had appointments at, and I was like, this is crazy.
Birdie had not yet received a proper diagnosis. The hope now rested on dermatologist Dr. Antoinette Chateau and geneticist Dr. Therona Nngwe.
Dr. Chateau and I had started a dermatology genetics clinic. So it's a combined multidisciplinary clinic. I think it was in about 2021 that we got her through to this combined clinic.
A diagnosis was crucial.
She had a very pendulous tummy and very, very soft, lax skin on her tummy, and also presented to us with hair abnormalities as well as very broad, short fingers.
And then we noticed all of the skin lesions that she started having. So a lot of scars that were forming.
And till today, just the slightest bump and her skin completely peels off. So we thought there's some skin fragility syndrome.
When the scars form, they heal with this linear type of lesion. There was lots of atrophy that was happening within her skin.
So we did extensive testing, and that didn't prove anything. So that diagnosis didn't come to fruition.
There were multiple skin biopsies that were done, and we used all of those to try and refine our diagnosis.
And the first biopsy came back and said it was absolutely normal, and the second biopsy on her toe came back as a possible fibroma. So then the diagnosis was revised, but it still didn't make sense because all the symptoms were not fitting into place.
It was actually quite a journey, so a lot of the rare patients, we say it's a diagnostic odyssey, to actually get anywhere in terms of a diagnosis.
Without knowledge of Birdie's parental history, they had no option but to resort to genetic testing. However, the options for testing in South Africa were limited.
So we have a test known as a microarray, and that looks at a person's cytogenetics or their chromosomes. And the microarray came back as perfectly normal. So there were no areas where there were big pieces of chromosomes that were deleted or duplicated.
Birdie's foster mom, Leanne, along with the medical team, grew increasingly desperate for a diagnosis.
Getting a diagnosis isn't important as such, but it does help us, especially with Birdie, to know what to expect.
Birdie was aging rapidly compared to other children her age, and it was important for her to understand that she has a diagnosis.
We need to understand what targeted therapy we can then offer the patient. And also we need to be educating other healthcare practitioners as to what the diagnosis is.
We need to offer these children some sort of support, diagnosis, management, and even the parents. The parents are very grateful, to be able to finally get a diagnosis and finally understand what's happening with their children.
Yet, a definitive diagnosis for Birdie remained elusive. Doctors Therona Nngwe and Antoinette Chateau facilitated whole exome sequencing for Birdie through their participation in a research study. This test was limited to only 50 children in KZN, with Birdie being patient number 36. Whole exome sequencing is usually very costly, making it inaccessible to most patients.
Whole exome sequence is a very special test that sequences the genes in one's body. And it looks to see if there are any changes or mutations or variants in the gene.
While awaiting the results of the research study, Birdie's skin condition started deteriorating. Leanne confided in Dr. Gokul, a private pediatrician who cared for their other children.
The same day that I had a conversation with Leanne about Birdie, I contacted the 2 doctors that were involved in her care in the public sector.
The 3 of them worked together and decided what tests needed to be done. And we had to raise some money for a genetic test to be done, which was then sent over to Germany. And then we got the results within 6 weeks.
The test results from Germany matched those of the KZN study. Dr. Nngwe says this illustrates the power of whole exome sequencing in rare disease diagnostics and confirms it can be achieved in South Africa with local sequencing facilities.
The test result came back and she had a change or a variant or a mutation in a gene called PDGFRB. And the mutation that they found in her is responsible for the skin lesions.
We actually got a call from the lab and we were emailed the results, say that she actually has a syndrome called Penttinen syndrome. So Penttinen syndrome is actually a type of progeria where you age progressively fast.
And we discovered that there were only 9 other patients worldwide that had this diagnosis made on them, and Birdie was the 10th patient. In terms of the specific mutation that Birdie had, there were only 3 other patients worldwide that were documented. 2 were in Norway and 1 was in India.
So she is an ultra rare condition, super, super rare condition.
Birdie was nearly 6 years old when she received her diagnosis.
I like to try and understand and know what we are dealing with. And I came across an email address for a professor that had studied Birdie's disorder. So I just randomly sent them an email, just like explaining who I was and that we have Birdie and she's just been diagnosed with this disorder. And I sent the contact details to Dr. Chateau and Dr. Nngwe, and they reached out to them.
Doctors Chateau, Nngwe and Gokul were invited to join an international study group based in Norway,
where we are specialists from all around the world that are involved in care of patients who are presenting similar to Birdie, not with just Penttinen syndrome, but other syndromes that have a similar variant in terms of their genes.
A skin biopsy from Birdie was recently sent to Norway.
And they're actually trying to culture fibroblasts from those skin biopsy, and they're going to expose it to 4 to 6 different drugs to see whether it's able to try and decrease that gene variant that she has. Then at least we'll be able to know what specific drug we can use.
While Birdie will never be cured, the diagnosis allowed her to access therapy and treatment to alleviate her symptoms. Initially, her occupational therapist felt hesitant about working with her.
Because it was so rare, it was difficult to find any information online about her condition. So I was a little bit nervous not knowing what to expect, having not worked with her. But on the first day she arrived, I just actually handled her like any typical child I would. So with similar goals, in the sense that almost putting her condition aside and looking at what her capabilities are.
Often with the genetic conditions, there's no cure because the change or the variation is in every cell of her body. So there's no potion or drug that we can give to cure it. But what this drug, Gleevec, will assist with is it will assist with some of the symptoms that she's having and try and decrease those.
Birdie may eventually lose her autonomy.
She has definitely lost a lot more range of motion in the distal portion of her fingers, so in terms of that ability to flex her fingers, so she's not able to flex as well as she could initially. So eventually that independence is going to be reduced.
Birdie's treatment is costly, and Kim and Leanne faced challenges getting her enrolled in their medical aid.
I think we waited 3 years. When we put Birdie on our medical aid, we had to obviously disclose everything of Birdie's medical background. So then they put a 12-month waiting period on anything to do with Birdie. So we couldn't do anything for 12 months.
It recently emerged that Birdie's medication from Norway costs 22,000 rand or $1,200 for a 40-day supply. Holler is working to raise the funds, hoping to interrupt the progression of the disease.
Some of these diseases can be treated for a couple of rand a month. This is one of the reasons why we have Nngwe and why we have this demonstration projects, to show that we can do this in South Africa. Yes, it is costly, but weigh up the costs, and then, to get that process institutionalized for medical aids, for the Department of Health to realize that this is actually a better way of doing things than the way in which we're doing it now, which is mostly ignoring the problem.
The Nngwe initiative aims to foster collaboration among existing experts while addressing skill gaps through education and training. This state-of-the-art program is the first of its kind in South Africa and across Africa.